Hey guys, welcome back to my channel. We have another video here. I think this will be class 4. Hopefully I am saying it right actually. Let me take a look 1 second on my YouTube channel. No, actually this is class 5. Sorry, I'm being really busy. As you guys can see in the lab, I have a few computers waiting for me to get repaired. I got 4 in the box in here. I got 12 in here, so very busy. The one I have in the bench is Acura Integra 2000. This is coming from California, and for obvious reasons, I cannot give you the full information of the customer. All I can say is from Ibarra. So Ibarra, this is your computer. The customer complaint on this one is that he cannot control the idle error control valve. So it's like giving, I guess it's giving him a code or not, working at all. The history also, they replace the complete engine and transmission and harness and computer, as far as I understand, and put this Acura Integra GSR 1.8 B-Tech on a Honda Civic. A lot of people likes to do that, and it's because it gives a lot of power, right? Obviously, it's a VTEC engine compared to the Civic. But so what I did, as normal, I went into all data, which I have it open here, and I'm using both. I got all data and I have Identifix. Um, Let me see, make sure you guys can see some of that. I will be kind of like sharing the screen with you and me. Hopefully, let me take a look at that. Let me try to focus a little bit on the screen. I'm gonna be moving the camera, so sorry for that. Should have done this before. Yeah, that's better. Okay, so what I usually do, and this was a little bit of a challenge because he wasn't sure if the computer was a 2000 or a 98 or 99, and it's a big difference. The actual Acuras, they go from, let's say, 96 to the 99, and then 2000 to 2004. I was able to decipher that this computer is a 2000 up to 2004. It has immobilizer. So when you have an immobilizer, it's a little tricky to work on the computer because you have to, again, trick the computer to think that it's also running, because if you give it too much RPMs, it's not going to work. But we'll see this as we go. So the normal things that I do, I usually check the data link connector, which in this car, for some reason, it doesn't show any powers on pin 16 or 4 and 5 as grounds. And truly, I wasn't able to communicate, so I just used my simulator, put the signals, and I started working on it. His complaint is not communication, so I didn't went that way. But so the other thing that I like to do is I go over to the wire diagrams as normal. So let's go over the wire diagrams, and I use a the non-OEM. The color ones is a lot easy to find the pins, and you guys saw me how I do it. I like to use all data more for this because it's well, as you can see, hopefully I am in the right car because I was looking at the 98. So 1 second. Yeah, you see this is the 99. I cannot use the 99. It has to be. Hopefully you guys saw that it was only 2 pages on that. So right now I'm in the 2000, which is what this car is. I'm going a little fast, so do not make the video too long. So powertrain management, engine controls, and that's an old data. So it's a little different from old data to Identifix. So in this one, we got more pages, as you can see. I already got the pinout, so it will be a lot faster. I know that we have ignitions in connector B, which is right here. So I'm going to do a zoom on that. I have also my oscilloscope. I got another camera on the oscilloscope, and I got another camera right in the computer. So you will be seeing all that at once. So let me do quick that. So we need pin 1. I'm going to select the wires that I'm going to be, is pin 1? Yeah, pin 1. And you'll see in a second where all this goes. And as you can see, spliced to pin 9, which is the other power. And I'm going to select in here because this goes to the PGM, the main relay, Honda's main relay. Not sure which one is the actual power, but yeah, we have another one, STS, that's a star. We don't need that one, so I'm not going to select it. So those are the two ignitions, and then we have a battery on pin 21. Same thing, B21. And then on the same connector, we got grounds on 210, 20, and 22. I also went in the computer, and you can do that because otherwise you need to put too many wires. You don't like in these two ignitions. I only put one because I check continuity between the two pins, and they're the same. So they're redundant powers or ignitions, and then redundant grounds. Well, in the car, you need them because you got a lot of loads, outputs, and sensors that needs ground. So the computer needs that to supply for the rest. But for itself, you can just put one ground and one power, or in this case, one ignition. The other one, the battery, is a keep alive. So the B21 is a keep alive battery. So the grounds is 2 and 10. I'm going again on the pin on the connector B. This computer has A, B, C, and D. D is not on this computer because it's an sorry, it's a manual transmission. So we have that, and then 20, sorry, 20 and 22. They're also together internally in the computer. Why is not selecting? Okay, now it did. I also have the crank sensor, which is on C8, and I have also the idler control valve, which is our problem, which is in B23. So B23 is right here. So it's called EA's, yeah, IAC B. It's just a two-wire idle control valve and is controlled by pulse width modulation. We will see that on the computer itself. So I'm just doing the homework with you guys. Sorry I'm not using the screen recording, but the program that I have, and I've been trying with on other ones. Did I just close that now? It's giving me issues. Like I cannot, the frame rate is different. It's giving me a whole bunch of issues to do the editing, so I'm not using it. So we said CA, right? Yeah, CA is crank sensor, and we have it right here. And that just, now we can hide the wires, and we can just see what we already selected. So this is the CKP, which is internal on the distributor, but it's a sensor itself. So it will produce this inductive sensor. It will produce a sine wave. So I select it like that. Sine wave 58 plus 1 on my simulator to create that signal. Again, I'm doing it with low RPM, so it worked good. So I was able to find all these pins and make sure they're all where as I need it. Come on, I just put a whole blue. Okay, now it's perfect. A little less. Yep. So this is all we need for this computer to work. And that's the homework that you need to do. So now, again, in the computer, hopefully you guys can see. I need my zoom glasses, even though I have this microscope for little things like this. Hopefully that doesn't affect the audio. I don't think so. I need something to point. I'm just going to use a screwdriver. The computer is not on. No. So inside here, and hopefully you guys can see there, is an A, B, C, and D, even though D is not used in here. So I put, all the grounds as I said. Um, that's what I also had identifix in here because it says, what it's a 8 is a 32 pin, and it tells me, where all the connections are, which in this case we don't need A for what we're doing. So we go to B. It's also, no, B is a 25 pin, and it tells me, when is one, where is nine, and all the rest of the stuff. You guys can see that. The way I look, it was for terminal voltages. Let me see if I have. It's a little hard sometimes. So the way that it says engine powertrain control module terminal arrangement. And the search that I did and I found it was terminal voltage. And or you can put ECM pinouts. I tried, DLC, and the search engines on both of these um, data service or identifics and all that are a little weird because you put DLC, it doesn't show anything, but you go for data link connector and it shows up. It's just a little hard to do. But so his complaint was that he cannot activate that valve, right? So I went in and did a homework. This is something else. Ah, wrong book. I keep, more information in there for myself. This is what I call reverse engineering. And let me see, you guys can see that well. And it's something to point. Should I do a close? Hopefully this light works. Yeah. So pin 23, B23 is our signal from uh, the IEC that goes into the computer. This one is going into a transistor, which is an NPN. It's a BGT transistor, and it has, base, collector, and emitter. The emitter on the NPN is pretty obvious, or like not obvious, like pretty normal will go to ground. But we will see that in some other cases it's not. It depends on how the application internally in the computer. So we have a ground, then the signal, which is going to the collector. That's the way the computer controls it. It goes to another transistor, which is a PNP, and that's pretty much a way, and then this one, the emitter, goes to another PNP, and then I had to follow more internally in the computer to reach all the way to the uh, microcontroller. I also have a signal coming from the activation to this NPN is coming from this X inverter, which is that's kind of like how I draw it. We have not many resistors, just one in here that goes to ground for this transistor, and hopefully you guys can see that. So I'm trying just to give you a little bit of a head view of what is in there. We have, it's a little hard for me to read without my glasses. Sorry for that quick turn. These are this is a EF39 transistor, oh, sorry, FR39, and this is just a 3-3, and that's the way that I look at it, and I was able to find it. So you need to do a homework on the internet to find those numbers and the data sheets. But so I was able to look all that, and let me turn this other screen and the camera on. I have to turn it back off. We're not going to need this more, so let me just get this one out of the way. All right, perfect. Now we have the camera. What happened? Didn't like that I move it. All right, guys, I'm going to get you closer so you can see this screen. It's going to be very hard with all these captures. I'm trying to share as much as I can with you. So let me do a zoom to that. But that's going to be a little bit on the way. Probably here. That's the best. Right there. Yeah, you guys will be able to see something. And hopefully I don't get too much in the way. So as you can see on the screen, I have, this is the transistor, the first, let me get the um, book out. That's my drawing book. So that will be 25D2382. That is an NPN. And so what I do is I go to Google and then look for that number, right? So we got 25D2, 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 382, 382. And just hit enter. 25D2, 25D2, 25D2. I put transistor in there because it's not showing anything. Two five D 2382. 25D 2382. Hmm. I don't know why it's not coming out. Gonna have to keep that in my. Is off. Yes. Let me put that number or data in the camera of the scope. Yes, 2D to 25D. Hard to read, right? I can do a better zoom than that. Let me. Make sure I got the right information. You know, you can see at the bottom where it says a meter. Usually these old computers, they share you that, like, diode, and you can see right here it says diode, and it has a diode thing, and this one is the FR39, which is the next transistor in place. And as you can see, I put, different color markers because I'm checking for base and I'm checking for emitter and collector. So I use different color to follow you know, the the um, the wiring, let's say, the trace in the computer. I just cannot. Well, I see D3. I don't know where that 25 came from. All I see is that D32. Sorry, D2382. Let me see if that comes on. Yeah. Mm-hmm. So that's how I look for it. Take this away. So it is a power transistor. It's a 2SD2, 2S, not 25, 2S. And this is that's why I couldn't find it because I was looking for a 5. It's my own numbers and my own lettering. I couldn't see it, but I'm not wearing my glasses, so that's why. But so we have, the way is built or used. Hopefully you guys can see that well. Base, collector, and emitter, and that's how I put it here too in my drawing. Too many wires right now, guys. I've been working. Hopefully it's not too messy. But yeah, so let me sure this is still recording, but the GoPro sometimes turns off. I mean, I haven't done much in here. But so this is the data sheet that I could find. Not really. I think I find so much more information, but I know that this is an NPN and this is base collector and emitter the way it is. Let's see if I find something else. Yeah, right here's the 2382 data sheet PDF. You gotta see, it's actually selected. This is probably what I went by. No data. Some of these websites, they're just, subscribe. It is just a nightmare, believe me. So I found it, and this is the way you do it. It's the same thing with the other one there, FR39. So I just put like this here too, FR39, and they are, pretty common. You see, don't ever click on that download sheet. I mean, some of them work. Some of them just try to open like, see, another thing. Let me see if this actually shows anything. Yeah, no, you see, this is a completely different information. So it's just a waste of time. When you cannot find like that, you can use the same SMD code. So you go to F. Remember that page that I put it on pretty much just in all the links of the classes. So you look for like F3. I don't think it's an F39 in here. FR, sorry. That's what I'm looking for, FR. And then we have, like I said, it's obviously that we're gonna have different transistors, but they're all here pretty much as NPN. So we can just select the first one. Just click on search with Google, and that's what we got, right? So general purpose transistor. That's, the dimensions and sizes. Let me see if I can find that data sheet. I should have this right here. Hopefully this one works. Yes. Okay, perfect. Yes, to remember the number. So is the 378K is the one we'll be looking for because there are different ones in here. So 378K, this is the one because even though like you can see the same thing, like this one has 1, 2, 3, and this one has 1, 2, 3. So be careful with that. As you can see, it has the arrow in, so this one will be PNP, and that's it's a very basic. This one I don't see any. It doesn't show any clamping or nothing that protects. The other one most likely will have it. But so to not waste too much on that time, this is just like I wanted to show you the way that I do on the board itself. That's what I want to have the camera on. Let me flip this as much as I can, and hopefully you guys can see something. So I'm going to follow my sketch and show you that it's actually the way it is on the computer. And that's how I did it. I just going to show you probably one of the signals, and then we're going to work on the computer. So I use just continuity. Make sure there is no power applied to the computer for this. And then, so we have 23 is going to the collector. So if we click, sorry, if we select the pin 23, which in this case is right here. So, and we go to the collector, which in that one will be the middle. See, we got continuity. So we know as a fact that from this pin 23 to the bottom, sorry, to the collector of the D23A2 is continuity. So it's going straight to there. It's not nothing else in there. But if I go inside now, let me plug this back in for the feature testing. Like if I go here, I'm going to go this like a dentist. So we have here, if we follow these paths, hopefully I did this right. Trying to get too many things at the same time. Sometimes it's hard. See if I can see that on the microscope, and you guys can see on the um, yeah, because I can see a lot better if I use the microscope and you guys focus in there. So again, collector, and then if I touch here, we got continuity to that pin, and we got continuity to this pin, and then we got continuity to this, which is the FR39. That is a PNP, and that is the emitter of the FR39 as I have it on my sketch. That will also go to another PNP, and it's a 33, which is actually, if I remember correctly, not too far away. Yes. Let me put him on the camera. And it says that it should be the base of the 33. So it's a little different setup. You see, we got continuity to there. And this pin right here is the other one. So I went with continuity, flipping the board, putting the other lead, finding the place. Sometimes it goes like some of the computers, they got multi layers. So you have to like just, touch around like if I go here like this, looking for to see which one gives me continuity. And that's how I do my reverse engineering. and start looking data sheets and see what I found. It is time consuming. Don't get me wrong. This is not like a 5 minute to to get to know what the computer works. And I like to keep those for future references. I mean, yeah, this is a 2000. I not might see too many of those, but it's a Honda. This VTX engine, they still use it. They love it, so no problem. All right, so this is how I did the homework, and I start looking, resistor, capacitors, everything is fine. I'm like, something is not right here because he's complaining about um, the idle control valve not working. Make sure I got you guys close in there. So I said, you know what, the best thing I can do is now let me put yep, I have that camera there, and now let me relocate you guys so I can work with more room. Sorry for all this going arounds, but I'm trying just to give you the best of all that I do. You can see the whole simulator from there. Perfect. Yes. So now I have all the pin connected, and uh, I am also again using C8, which is pin for the crank sensor, and I start to use an air control valve, which is it's just a load. I'm using an incandescent bulb. That one draws almost 1 amp, which is what that valve will um, draws well. So I selected in this case in my simulator. I'm not going to show you too much of that because you got. Sorry, I got hung up by a call. So, what time is it? That's probably my wife coming in. Uh, I don't know. Either way. So, what I was trying to say is I can show you the whole overrun on how to do. If you guys end up getting one of those, just let me know and I can give you a class of like the whole thing if it's necessary. For this case, I'm just selecting um, a sensor, an RPM signal of 58 plus 1, and this will give me, when I run it, I have power and I got ground. And you guys can see that I have also um, a light. I'm going to go into different hertz. I'm going to go out, turn that off. And hopefully you guys, it's starting at 100 for some reason. So I'm going to the collector, which is where this signal is coming from. Not sure if you guys can see or not there. And I need to put the glasses. I don't want to short out anything in here. I don't know what I took it off. Hopefully the audio is good. All right, that's better. I love these little glasses. They're very handy. You gotta be careful. Everything is on. I'm drawing probably 500 milliamps, so that's very normal in a computer. I'm gonna go to the collector, and you're gonna be seeing a signal. I need to move that. So as you can see right now, we have a lot of ground. The low obviously is the ground, and high is the voltage. So yeah, it's actually 11.9 to 0, but it's very minimum activation of the valve, and so as the bulb is telling us the same thing. So I'm going to change the frequency. Happening. I have to come back. Let me take the RPM signal off. All right, that's what I wanted to show you. Look now the difference without the RPM of this signal. I'm gonna go to 30 hertz. I'll show you the signal in a second that I'm injecting, but so you can see it's very dim. Now we have a big waveform high in very minimum ground. That's why the bulb is barely coming on. But if I put an RPM signal, immediately changes, right? And I can make it go. Let me change the time base in here. Yep, like that I can see that better. Trying to select. Trying to make a change. The immobilizer is not letting me. See, it's like when it's already with the signal, I have to actually turn the computer off and run again. You guys can see that there. It's immediately activating it. Let me just double check my signal on the scope. I mean on the simulator. Make sure it's the same thing that I was using before. And this, as you can see, is just a sine wave, and it has, a sync. I can see. All right, let me go back. I want to see RPM, run. No, I don't need a square. I need a sine wave. Yes. I don't like how it's now staying on. Instantly. Yeah, right now the signal is almost no ground. The light is very dim, but it's changing instantly to full. It's not changing as it should. Is this what he's experienced? Hmm. Let me change select a different sine wave. That there changed for a second. What is happening is this. You see right there. Okay, this one is working better. It's just the same way that I'm selecting. You see, this is the way it should work, where it works. Let me get the sample rate a little, take the cursors off, set up a trigger, and that is perfect. So 70 plus 1 in 2003 hertz is doing that. But I mean, I'm tricking the computer this way. The computer thinks that it's receiving a signal for cranking and is trying to open and close the valve as a way it should. So the system is working good. I was a little worried about, not being working fine, but no, it is working good. So we can see that everything is there. So for me, the problem, the Ibarra you have is harness. Your connection is either the harness might got damaged when you were, moving it around. Something is not exactly as it should, but the computer is working good. I wanted to see activations. So let me see what the base of this transistor is. Gonna move you guys just 1 second. Want to make sure I don't short anything. In here, it's not really much of a problem. Just want to see the signals. Because see the base of this one, it connects it to the other one. So everything is pulsing. Let me see how the emitter, which is, well, the emitter should look exactly the same as our, what we have here, a very small signal. So in here, we'll have to change the voltage. I can't wait to get my Pico. This is trying to do automatically, and then goes off the chart. Trying to move it down. That's right here. It's kind of weird. 2 volts is too small, and then 1 volt goes off the chart. I'll probably use the other scope for this. You see the actual valve is activating itself very good. You see how it changes? I can change with this sine wave. I can change the activations really, really good. Let me go back to the collector. That's our power transistor, and that's the signal. Let me change it to automatic, and let's change the time. You can see how it's changing the pulse width from there to there. So if I change the speed to 1900, it's a little different now. It stopped doing the activation. You see that? So the sweet spot to do that is 2003 hertz. The computer doesn't understand what's going on, and so it's trying to open and close a valve. Like, okay, is the car cranking? I need to open that up and see if it starts. See if I receive the signal from the immobilizer or no. Let this car run. But the valve is working. So I'm sorry, Barbara, but check your harness. So guys, this is how I checked computers. What I usually do, since I have this in here, is use my scope. Let me turn this off. Use my scope and then probably select two channels and then record. You know how it looks the base of transistor one. I usually also on my notes in here, and this is for you guys too. I just dropped my my lid, but that's not a problem. One thing that you should do when I start to have all the numbers in there is just transistor one and then transistor two and then transistor three. So that's it, right? And we actually got a number for right here, which is right before and this is, I forgot to put, well, it's a 33. It's got to be another PNP. Yes, they're all PNPs except for this one. This is an NPN. And it uses this as this way of connection to turn it on and off. This is the way the computer is activating and deactivating the pulse width modulation to make sure it goes off. Because otherwise these transistors can, stay on very easy. So that's the way the computer is making it sure that it is on or off when it needs to be done. But everything is fine. I don't see any problems. I hope you guys liked. This is live. I didn't prepare anything. I was actually working on this computer. I said, I want to share this with you, and also I want to share it with Ibarra because he think that the computer was bad. No, I don't see anything wrong with that. Computer is working good right there. I mean, that's a steady. Doesn't like the RPMs that I'm giving it, but right there is the sweet spot. And that wasn't a little delay because I was still selecting. When I release the bottom is when it's gonna start, right there. But yeah, everything is good in here. So you guys, this is how I do it. This is how you work in any electronic. Again, laptops and cell phones, you can get, schematics online, so you would not be needing to waste all the time that I have to on this. But and they pay well. They don't pay bad either to repair. I like this. For me, this is a lot of fun. So I hope you guys like the video, and this will be class 5. That's it. I see you guys next time. Don't forget to subscribe. So hopefully you guys like the content, and this is how you control an output. Even if you cannot see it with a scanner, you can see it with a test light. So nice and easy, simple. All I'm using that simulator is to put power and ground. I can use you know um, my power supply. Is that dying or what is doing? And it had a fresh battery, but I'm done with you. Yeah, the battery is dead. This thing is been eating batteries like crazy. Let me turn this off. If it goes off. Yeah, now it's taking a picture. Another one. Yeah, keep taking pictures. Turn off. Ooh. And that was a fresh battery. It didn't last the whole class. But well, anyway, that's something else. So that was what I was saying. This is, how you test an output. The only way that you can test an output is with a load on it. Something that kind of uses the same amperage. That's what you're looking for. Like that you stress, in this case, the computer, the transistors, to make sure they can, activate and deactivate as they should. And this is the way you do it. Some of you guys were saying, oh, inputs are really easy. It's part of everything. Without that crank sensor signal, I would not be able to use or see this output. So I try to use these classes, this is a lot, a lot deeper than what I wanted to share, but I can see that people is not, too excited about simple electronics and they want to see more hands-on repair. But, sometimes you're not going to understand if I just jump from here to there. You know what I mean? But so I think that overall, I show you how I do my homework, finding information on what I'm dealing with, because sometimes you just get like FR. What is an FR? I'm giving you a lot of my tips and tricks, and this is how I do it. Yeah, it takes time to reverse engineer and find out what a resistor, a capacitor. I also had this tool in here I wanted to share with you too. Let me move this because when I'm working on the boards, it's not just all oscilloscope and multimeter, because the multimeter is good for resistors and so, but if you really want to be accurate, you want to get one of these ones. This is from BK Precision. Make sure I'm doing it right. Yeah. And this is an LCR meter. So with this, you can check transistors, you can check, sorry, not transistors, capacitors. Let me turn that computer off. That's good enough with that. It's very accurate. When you're checking resistors, when you're checking capacitors, make sure, especially with the capacitors, that you are um, are careful with the polarity, because they're, especially if you're using a multimeter, because multimeter will charge the capacitor in order to test it. With this one, it's under a frequency with a very very small voltage, and that's why it's very very accurate. And it has some other, especially this one that I got, it has some other leads that I can use for this same thing, and it has regular positive and negative grounds and all, but this is the one I like to use the most because I can just clamp it into the capacitor and then just, let go. I don't have to be staying in there. So again, this is a very good tool. This is the BK 880 LCR meter. I mean, this is only if you're working on this, you need to buy. Don't buy this if you're just, doing this for fun. It's just not a cheap one. But it's one of the very good ones. In order to release this, just left and up. I had these tools because I need it. It's the only way that I can accurately test a capacitor. Sometimes you need to remove it, sometimes you don't need to remove it, and that's what I got these tools in here. And again, this is the way it goes. So I will be showing more how to test now the components, but this is how you do it. I also know that I already show you the BGTs. The you will be checking from base to collector. Make sure I'm saying it right. Sorry, from base to emitter in the PNP to see the voltage drop. If it's an NPM, it will be the opposite. But you guys saw that in the other class. If not, go over to class. I forgot. It's class 3. Just make sure that you check my videos, and you will see I put in the name of the class in there when I'm talking about transistors. I will be doing. I think my next class, because I always say I don't want to make it long, and it's always each one has been like over an hour. Let me take this camera off too. Then I kill the batteries. Um, it would be about the 5-volt reference and the voltage regulators and the power supply. I want to show you how to test those. This was something I had this on the bench, and like I said, I wanted to share with this with you guys. And this is a real time repair, at least a test, because there's nothing wrong with the computer. But this is how I do it. Okay, guys. Again, see you next time. Hopefully you guys like the content, and don't forget to subscribe. See you next time. Bye bye.